He's going to be helping us reinvent the wheel, so give him a hand.
Hi, I'm Nick. Like you said, I work in New Relic. I work on our browser application monitoring stuff. So I write the really fiddly, like backwards compatible ECMAScript 3 instrumentation that we inject into our end users' browsers. It's really complex stuff. It's about wrapping the world, catching errors, getting stack traces, interacting with XHR objects, that kind of stuff. So a lot of my job is to fight that complexity and keep building a flexible application. So I'm going to be talking about some of the techniques I've used to do that, mostly involving custom event emitters and reinventing things that people often take for granted. So the biggest thing is, of course, for one bug, you want to fix it in one place. That's pretty straightforward, but even more important than that is reuse concepts throughout your applications. So if you can reuse an implementation, that's great. But if you have a concept that applies in multiple places, keeping that the same helps people approach your code base and be able to modify different parts as they go. One of the biggest problems that comes up, though, when you're trying to reuse concept and reuse implementations is just a for-in loop or a for-index loop is like the easiest thing to mess up. As soon as you do something asynchronous from inside that loop, all the loop variables that it sees are all their final value. It's one big screw up. So invent your own. There's no reason you can't invent your own map that will just bail at the when it's done, or like if you've got a for each that you just want to be able to do special stuff with. There's no reason not to write it from scratch. So one of the biggest things about fighting complexity is recognizing the patterns in your application. Some ones that I found were like queuing for later. This is something you find in like Google Analytics, pretty much anything that you have to load up a bit of JavaScript, and it's important that you catch everything that happens, but then you can't process it until later on. So what most people do is they make an array, they just push everything on there, and then you've got an array of usually arrays with positional arguments in them. Things like, the type or, some modifier for it, and then some times, and some of those are optional. And you end up with this like huge switch statement at the end to iterate over the array and figure out what's happened. But we already have a pattern that means handle this somewhere else, and that's the event emitter. And if you want to queue things in an event emitter, you can just save the emits up if there's nothing listening to them, and then play them back later with a custom implementation. That's a pretty easy one. Another thing is optional features. If you have like two modules that can interact with each other, but they're not always included in the same build, if you want to be able to like have an Alice module that will like talk to a Bob module, but you don't know if they're both on the page, if you share a reference to an event emitter, if you require an event emitter that they can both see, then you can have Bob emit an event on Charlie, the third event emitter, and then it can, and then Alice can listen for that event, and they can talk without being dependencies. Another thing is an object-keyed map. So we've got great support for this coming in ECMAScript 6. It's going to be pretty awesome. We can have an object where you give it an object and get back the contents, but that's not a thing yet. And you don't really think that this falls into an event emitter pattern at first, but like about the third time that I was handwriting this thing that would put an ID on an object and then would save that ID as a value that we could then like look up stuff related to that object with, I realized we had to find something. And it turns out if you emit events with an object as a context, you can treat that object as a store and keep context across asynchronous boundaries. Another thing is method wrapping. So method wrapping is something that people often screw up when they're trying to monkey patch something. want to add their own behavior into an existing thing. And that's something you really want to be careful about and really want to try and put it all in one place. You want to keep the this context the same and pass that through, and you need to keep the arguments the same or modify them as you see fit. You want to be able to like time from one side to the other. Those are all things that you can do with events. So you might be an event emitter if you're passing multiple callbacks in. If you've got a success and an end, and then maybe you want a progress callback and you're sending those in as 3 distinct arguments, maybe you should be looking at an event emitter. If you're adding callbacks to special properties, we all have experience with the DOM and doing thing .onReady state change, and that's just an awful way to deal with events. It's not an event emitter; it's just a special function. If you're adding things that onReady state change, and then you have to look at the thing to see what ready state it's in, definitely worth thinking about turning that into an event emitter instead of some sort of magic property function thing. Another is if you're checking for optional callbacks. If calling back is optional, definitely consider making it an event. Then they can choose if they're listening or not. And we're not just talking about Node's event emitter here. Node's event emitter is great, and the browser event system is very good too. But they don't have many features. They've got a very set number of things they do. Node's event emitter especially has a mostly good API. You can listen to things with on. You can emit events with emit. You can get all the listeners for a type with the listeners function. And if you really want to monkey with stuff, you can get the underscore events object and do whatever you want to it. But it's got a limited feature set. It doesn't let you extend it in any way. The code base is entirely hand optimized for V8. So if you're using it in the browser, it's not necessarily faster than something that wasn't. It might be, but it's also really, really big for turning into a browser module. And it's not tailored for your use case. It's got stuff that you don't need. It doesn't have things that you do need. So why not just reinvent the wheel? Why not build one yourself that is simpler and easier to understand? Reinventing the wheel is usually used derogatorily. People say that you shouldn't reinvent the wheel because other things out there are better tested, they're more robust, they've got more people using them. But I think if the parts that are out there don't fit your application, you should reinvent them. So I was going to do a bunch of wheel analogies about square wheels and stuff, but we all kind of get it. Like it's pretty straightforward. You don't settle with what you've got already. And if you've got something that's not quite right, it's better to build something from scratch, usually using parts that are already existing. Like if you're reinventing a wheel, you don't have to reinvent the hub every time. You can use that piece that's there. So some people accept reinventing the wheel as a good educational exercise. But that's, I don't know, they say, you can reinvent the wheel, but don't put it in production. You better throw it away at the end. I think that's pretty silly. If you come up with a new approach that fits your use case, then you should definitely put it in production. And you should really, really publish it for other people to use. Because if they come up on the same problem and they can find your solution, then they can reinvent some other wheel. So this is the first demo. Okay, so we're going to build a quick custom event emitter. What we've got here is just some boilerplate. This is testing our event emitter. We're going to create it with the create EE function. We're going to emit the foo event, which shouldn't do anything because there's no listeners. And we're going to listen for a bar event and console.log the first argument and return the second argument. And then we're going to console.log the results of emitting the bar event. You'll notice one funny thing here. I'm using arrays as the second argument into these event emitters. That's because these aren't set up as variable args functions. We're just going to apply the array that gets sent in. It kind of simplifies things and makes it easier to think about. So the first thing is we need a place to hold our events. So I just use a simple events argument, and then we're going to return our interface out of this. So we need an on function. It's pretty common. Emit, same as node, and then listeners. Listeners and underscore events are things that I've tried to reinvent several times, and I keep coming back to, I don't know, this is really the most straightforward way to do it. So, stuck with this. So for an on function, we want to take in a type, we need a handler. We're going to register that handler so that we can see events on it later. So to get that, get the listeners to add to it, well, we want to say we don't want to mutate the array, so we're going to reassign it to the events type, and then we're going to assign the listeners for that type to it. And then we need to add the handler, so we're just going to concat the handler onto the end here. So this is simple copying the array that of listeners that we've got and adding the one that we added to it. Then to emit, well, let's do listeners because we depended on it and we don't have it implemented. So to add listeners, we're going to simply return the events type. This seems like, why would we have an individual function for this? A lot of times you do something more robust here. You'd copy it so that people can't mess with it. I'm simply going to OR it with an empty array. So this is how we create that array the first time an event listener gets added. So we always fall back to having an array to add events to. And then emit also takes a type, bit of a common theme there. And then we're going to take the args array to apply to our handlers. And we're going to return a mapping over our listeners for the type. And we're going to give that a function that calls functions. So each function gets passed into this function in turn, and we're going to apply this and the args to it, but we want the this from the outside here. So we're going to say self, and then we're going to var self equals this, which is a horrible kludge, but it's really the most effective way to do this a lot of the time. And we're going to apply the args and close all that up. All right, so we've got an emit, an on, and a listen. We go up here and we look at the code we're going to try and execute, creating that event emitter. And see, I'm going to go ahead and I've got a button here that just lets me execute everything in the editor as it is. You can see we, you can't see the same thing I can see. All right, there we go. You can see we emit bar 1 and return 2. So this is a complete event emitter implementation that's fits in a dozen lines of code or so. So it's pretty easy to do. Something you can hand roll whenever you need it. You can modify to your own use cases. But yeah, it didn't have any features. It's stripped down. It lets you only use the API that you need. Off is usually an event or a function that you need. You want to be able to remove handlers that have been added to events unless an event is going to happen forever, or you've got a situation where you know that the object, the event emitter, is going to get garbage collected before you need to remove any references to it. But yeah, so something new. What are good features? I've been talking about you can add features to event emitters. What do you want to add? A wildcard character is a huge one. If you can listen to any event that happens on an event emitter, regardless of the type, you can get a lot of information about what's going on. You can sort of observe other things. Inheritance. A lot of times, if you've got a nested structure, like the DOM, where you can bubble events up, you want to do that with arbitrary JavaScript stuff as well. So one way to do that is to have event emitters that can inherit from other events. You can also have like a roll-up event emitter that listens to a whole bunch. Asynchronous emit, that's emits synchronous by nature. There's no reason that you can't make it asynchronous, though. It does slow down performance, but sometimes that's the thing that you want. You can queue events like we talked about earlier, cache events that have happened, so a new event emitter always gets something. We're not going to mix them all together. That would create just a really incoherent glob of crap that wouldn't really be useful in any way. But I'm going to show you how to add my two favorites together, the wildcard and inheritance. So I've got a nodes event emitter here. So this is like the proper event emitter. We're going to mix functionality into it. So you can use it with any of the built-in node APIs. You can use it with things that have been handed to you out of other modules and that kind of thing. And I've got a couple of modules I'm requiring here from me for the novel event emitter, which is some libraries I've been publishing recently. Me inherit lets you inherit, and me wild lets you mix a wildcard in. So we're going to do the same thing where we've got this example code. We've created an event emitter using the custom EE method. We listen for star events, and we're going to try and emit something on A, and just say a thing happened. When we run it, fails horribly because we haven't implemented anything yet. To just create a normal node event emitter, we're going to say var EE equals new EE, call that, and then return that event emitter out of our create E function. So now we don't get any errors, but we don't get anything logged either because we don't have anything listening to that A event. So to get that event firing on star as well, we're going to mix the wildcard thing into the event. So we can say ee.emit equals wild ee.emit. So we're passing in the original emit function to wild, which is then going to make sure it calls the wildcard character when it needs to and returns it to the method and puts it on the original event emitter. So when we run that, a thing happened, which is pretty awesome. So now you can use this to mix into any node event emitter that you want if you want to observe all events. The next thing we want to do is inheritance. So we can create a hierarchy of objects here and emit an event from one that's deeply nested and watch that event get propagated up. So to do that, we want to be able to create an event emitter from an existing event emitter. So we're going to go ahead and mix in a create method here. And what this will just do is return a new event emitter with that inheritance intact. So we're just going to say return custom EE and call it. So no more errors, but we didn't get those other events that fired. That's because we didn't actually make that inherit anything. So if we pass in ee.emit, and then we're going to bind it to EE, so we don't lose the context of that function as we pass it around. Then we've got old emit coming in up here in the custom event emitter. Now we can mix that in for inheritance. So we take the original emit, and then we put in the old emit. And we run it, and we see the events coming through that hierarchy of event emitters up here. So we can say, okay, Baz emitted an A event with 1, 2, 3, and we console.log that on star on foo. So you can see some really complicated patterns that start to emerge, but it all has a individual place that you can affect it, that you can make these things happen. So to verify that these are actually happening on the object we expect, we can say foo.bar.on A and see what this .message is. So if this .message is, oh my God, Zor, then that means this is being emitted on that bar object. And it is. So, oh my God, Zor, a thing happened. Yeah. So, reinvent often. There's no reason you need to accept the givens. Yeah. That's it.